Hey folks, so today I'm going to tell you about something called dark matter. So dark matter, no one actually knows exactly what it is, though we do know some of its properties. Dark matter is something of a mystery. And to show you what kind of a mystery it is, I'm going to give you an example. Imagine you've got a bag, right? And inside of the bag, you're going to put three 10-pound weights. You can tell they're 10 pounds not just because it says 10 pounds on them, but because you can put them on a scale and weigh them. And yeah, sure enough, they come out to be 10 pounds. So when you put all three back in the bag, and then you put the whole bag on the scale, you would guess that the bag would probably be 30 pounds, right? But no, turns out the scale says 100 pounds. Well, something's got to be going on here, right? There's got to be something else inside that bag that we're not seeing. That is kind of the basic idea behind dark matter, except instead of a bag and weights, it is the galaxy. So this is an artist's impression of the Milky Way galaxy. And the reason we think that there's dark matter here is because we have a lot of different ways of weighing a galaxy, almost as if we're putting it on a scale, and it never comes out to be the same as just adding up the stars and the planets and the gas and the dust and everything that we can see in this Milky Way galaxy. All that stuff put together falls way short of the total mass of this galaxy. And that's not just true of the Milky Way, we think that's true of every galaxy. So there must be a lot more mass in here that we cannot see, and we call that extra mass dark matter. So one of our first clues that there's dark matter came when scientists looked at the way this Milky Way galaxy works. We would have expected it to work something like the solar system. In the solar system, you have this big central mass. This is the sun, and the planets that are the closest to it, especially Mercury, is whipping around the sun very quickly. But the planets that are further out, these are moving a lot more slowly in their orbits. And that's because they're further away from the sun's gravity, they're not being accelerated as much. So you would have expected that the Milky Way galaxy would work the same way, right? I mean, even though this is a much bigger and more complex system and it's much more complicated, you would expect it to be basically the same principle. Right here in the center, you've got a huge mass. This is called the Bulge. It's a very high density region with a lot of stars packed tightly, and this creates a big mass, creating a lot of gravity. And here's a lot of stars that are orbiting. So we would assume that this is basically the same idea as the solar system, that the stars that are orbiting closest to the Bulge would be going the fastest, and the ones that are further out would be going more slowly, just like the planets. But it turns out that actually the stars that are close into the Bulge and the stars that are far out are going at roughly the same speed. And that is fundamentally weird. That is different than what we would expect. So upon study, scientists figured out that these stars aren't really orbiting this bulge in here. This isn't like the solar system. The stars are actually orbiting basically a shell of all the matter inside of their orbital path, and that matter is a lot more than what we can observe. So basically there has to be some extra matter distributed throughout this galaxy that we cannot see, which is what the stars are really orbiting, because the bulge's gravity by itself is not enough to account for all these stars' extra mass. To give you an idea of how the dark matter we think is distributed throughout the galaxy, this is an illustration right over here. So here's the galaxy once again, and this is the disk, and right here in the center, that's the bulge. And this big blue circle around it, this is like a sphere, like a spherical blob of dark matter. And the part of the galaxy that we can see is just kind of like this little thing in the middle of it. The dark matter is distributed evenly throughout the galaxy and extends well beyond it. And so this whole sphere as a whole, this is called a dark matter halo. We think that every galaxy has a dark matter halo. And here's actually a photo with some contour lines overlaid. This is a galaxy cluster. There's 4 galaxies here, 1, 2, 3, 4, and the contour lines are showing where the mass is concentrated in this cluster. The way we can tell is because see how the stuff behind them is kind of, like the image is kind of distorted. This cloud of gas in the background and the galaxies are, it's kind of distorted. That's because the incredible mass of this galaxy cluster actually bends the path of the light coming from background objects so that it looks distorted. It's actually, it really is like looking at it through a magnifying glass. So we call it lensing, gravitational lensing, because it really is a lens created by gravity. So based on how much lensing there is, we can figure out where the mass is distributed in this galaxy. And you can tell that the mass is mostly distributed here where there's a galaxy, here where there's a galaxy, here. But then over here it gets a little weird. You can see that there's this bright part, that's the galaxy, but then the mass is concentrated actually a little bit over to the left of it. So this is a place where the dark matter has, like the dark matter halo, has actually been separated from its galaxy. It's actually been torn off. Researchers think this must have happened as the galaxy passed by another massive object. So this gives you an idea of how dark matter is really distributed throughout galaxies. And we think that dark matter, these dark matter halos of galaxies play a significant role in the universe at large. So this is a computer simulation of the universe at very large scales. Every point of light you're seeing here is multiple galaxies, clusters of galaxies. And all of these filaments in this sort of like sponge-like, almost spiderweb-like structure are all many galaxies just sort of strung together. And this whole like grand structure wouldn't be able to hold together if it wasn't for the gravity provided by dark matter. Without dark matter, there wouldn't be half as much gravity, and this whole structure couldn't hold together. So you can see that dark matter is a very significant force in the universe. But the question is, what is it? So that is a question that scientists have been trying to answer for a long time, and as with everything in science, scientists always start with the simplest answer. And they thought, hey, maybe dark matter is just things we would normally expect to see in space, like very large, for example, brown dwarf stars and planets and chunks of ice and all sorts of things that you would expect to see in the halo of a galaxy. And it's just that there's a lot of them and that they're out of the way of any stars, so that's why we can't see them, and that's why we call them dark matter. These objects are collectively called machos, or massive compact halo objects, and scientists have done a lot of surveys using powerful telescopes and computers and all sorts of stuff like that, and we have found a few of these, in the halo of the galaxy, but we don't find enough to be able to we haven't found enough. If this was if this was really making up all the dark matter we could see, then we would be seeing a lot more of these. And we don't. So it's probably not the machos. Another possibility was black holes. And black holes, we look for, once again, gravitational lensing, because a powerful mass like a black hole creates gravitational lensing. And we look for these lensing effects in the halo of our galaxy, and we do find some, but not nearly enough that it's plausible that black holes could be making up this dark matter. So it's not black holes either. We ended up deciding that dark matter has to be basically these little particles, basically like clouds of dust or gas that's just distributed throughout the galaxy. But it has one very important feature that makes it different than all the gas and dust we know, which is that it doesn't block light and it doesn't reflect light. For example, this is actually a photograph of the Milky Way galaxy, and we're looking at it edge on. So this whole thing is the disk, and the bulge is right here in the middle. And you can see that it's not as bright as it looked in the previous photos because of this dark band going through the galaxy. And what this dark band is dust. The dust is actually just blocking some of the light that's coming from this bright bulge in the center of the galaxy. That's why we can't see all the light from it. So if dark matter could block light, then we wouldn't see this little piece poking out of this bright spot. We wouldn't see as much light poking out as we do. A lot more light from the rest of the universe would be blocked out. And we don't see that. That makes us think that dark matter cannot absorb or reflect light. Light can just go right through it. And that makes us think dark matter is probably not interacting at all with electromagnetism. If that's true, it could pass right through the Earth like a ghost. So that's very interesting, and the question is, which particle is it? We know one thing we know for sure is it's not any of the particles we've actually observed. None of them could fit the bill. The only other possibilities are weird theoretical particles that physicists have theorized but have never been observed. One possibility is WIMPs, or weakly interacting massive particles. That's the leading possibility. There's also other things like axions and all sorts of other particles. We don't know which one of those it is, and physicists are trying various different searches to try to find to look for those different particles separately. So far, none of those searches have come up with have found it, and we're trying all sorts of new, different, creative approaches. Some physicists are thinking out of the box and reimagining dark matter entirely, and really only time will tell what dark matter truly is. So that is my talk on dark matter. Thanks for watching, folks.